Hello friend, this is Arindam. Welcome to our YouTube channel Learning and Creativity. Today our physics chapter is gravitation. We will learn the basic of gravitation and solve some of the numerical problems related to gravitation. So, before jump onto the today's topic, please watch my video till end and please subscribe my channel. First thing first, gravitation. Do you know what is gravitation? Earth attracts everything towards it by an unseen force of attraction. This force of attraction is known as gravitation or gravitational pull. You, me, apple, or any object of the earth is attracted by the earth and its direction is towards the center of the earth. This attraction is called gravitation. Earth attracts everything towards it by an unseen force of attraction. This force of attraction is known as gravitation. You know, all of you know the laws of motion, Newton's laws of motion. Now you will learn Newton's universal laws of gravitation. Gravitational law. Suppose there are two objects. One is the large object, mass is capital M. Another is the small object, mass is small m. And the distance between large object and small object is d. That means small d. So, as per Newton's laws of gravitation, the attraction force between capital M and small m is directly proportional to the multiplication of their mass. That means F is directly proportional to m into capital M into small m, and F is inversely proportional to d square. F varies m into m, F varies 1 by d square. If we combine these two things, this one and this one, you will get F varies capital M small m by d square. If you want to remove this sign, varies sign, you will need to put a constant, that is gravitational constant, capital G. F is equal to G capital M small m by d square, where G is a constant and is known as gravitational constant. Value of G is, you should remember, it is a very large digit, but you need to remember. And most of the numerical problems, some of the cases it is already given. Value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Why this unit is this type? Because if you find the value of G equal to F into d square by mm, right? F is Newton, d square is meter or centimeter, Newton meter square, and mm is gram into gram, that means kg square. So as per SI unit, Newton meter square per kg square. Clear? G is called universal gravitational constant. So in this slide you will learn what is gravitation, what is Newton's universal law of gravitation, explanation of Newton's universal laws of gravitation, and what is the value of capital G, that means universal gravitational constant. Clear? So we will go to the next slide. Definition of G. So you have find the value of G. Now we will learn what is the definition of G. When capital M equal to 1 kg, small m equal to 1 kg, and d equal to 1 meter, if all are 1, then F equal to G. You know the formula, F is equal to G capital M small m by d square. Clear? So capital M small m and d are 1 kg, 1 kg, 1 meter. Then F equal to G. The universal gravitational constant, the force of attraction of two point masses of 1 kg is kept at distance of 1 meter. So definition of G is the universal gravitational constant, the force of attraction to point masses of 1 kg kept at a distance of 1 meter. So this is called gravitational constant. Characteristic of gravitational force. Number 1. The gravitational force does not change with the change in the medium between the point masses. Suppose two point mass m1 and m2 kept in air. The attraction force will be F, and if two masses kept in water, the attraction force will be same, and that will be F. So the attraction force doesn't vary with the medium of the masses. Clear? Next, point number 2. F12 means attraction force from body 1 to body 2 means force on mass capital M due to small m, and F221 means force on mass small m due to mass m. F12 equal to minus F21. This is the Newton's third law. If you have good idea of Newton's motions of law, I have already published the video of motion and Newton's laws of motion. You should watch this video to clear the idea. So this is the Newton's third law. F12 equal to minus F21. Every action have equal and opposite reaction. This is the Newton's third law, right? One note: the distance d is replaced by capital R when one body is Earth. So in previous discussion we have discussed m1 is a body, m2 is a body, but at that time the distance will be measured by d. But when one body is Earth and another body is any object, at that time the distance will be r. R means radius of the Earth. So that is defined by r. Clear? Everything is surface on the Earth, so the distance should be the radius of the Earth. Next topics. Effect of gravitational force. What is the effect of gravitational force? Number 1. Snowfall and rainfall is possible because of gravitational pull of Earth. If there is no gravitational force, then rain and snowfall will go upper side, not the surface of the Earth. Number 2. The gravitational force keeps a satellite orbiting around Earth. You know, there is some natural satellite, that is moon, and some artificial satellite just like Aryabhatta 2, Mars orbitary motion, and different things. They are rotating Earth or moon due to gravitational force. So the gravitational force keeps a satellite orbiting around Earth. And number 3. Tide in ocean is a result of gravitational force. So there are 3 effects of gravitational force: snowfall, rainfall, satellite, and third one is the tide in ocean. Now, what is the magnitude of the gravitational force between the Earth and 1 kg object on its surface? Now, the distance is r. R is the radius of the Earth. You know what is the radius of the Earth? It is already given. Radius of the Earth is 6.4 into 10 to the power 6 meter, and mass of the Earth 6 into 10 to the power 24 kg. Very easy. From Newton's laws of gravitation, F equal to G m1 m2 by r square. M1 is the mass of Earth, 6.0 into 10 to the power 4, 10 to the power 24 kg. M2 is the mass of the body, 1 kg. And r is the distance between the two bodies, radius of, that means radius of Earth, because the body is in surface of the Earth, 6.4 into 10 to the power 6. G is the universal constant. Value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Newton meter square per kg square. By substituting all the values in the equation, G, put the values of G, put the value of M1, M2 and R, you will get F equal to 9.8 Newton. This shows that Earth exerts a force of 9.8 Newton on a body of mass 1 kg. The body will exert an equal force of attraction of 9.8 Newton on the Earth. Clear? Next, what is centripetal force and what is centrifugal force? Centripetal means force towards the center of the circle, and centrifugal, that is opposite to the center of the circle, is centrifugal. Fugal means far, petal means near to center. Centripetal is defined as the force that is necessary to keep an object moving in curved path and that is directed inward toward the center of the rotation. Suppose you are rotating a stone by holding a ribbon and you are moving around your head. So the force extracting to your side is centripetal, and force opposite to you, that is centrifugal. Just like this. This picture clearly explains what is centripetal and what is centrifugal. Suppose this car is moving. This direction force, this is centripetal, and opposite to this is centrifugal. You remember the F centripetal, the force F centripetal, mv square by r. R is the radius of the circle, v is the centripetal velocity, v square by r is the centripetal acceleration. So mv square by r. Here also Newton's second law. F P is equal to mf. F is equal to ma. Force F equal to m is the mass, s is the acceleration. So this is circular motion, right? So here m and this is acceleration, v square minus r. Clear? And suppose this is orbit, velocity, this is these things. So centripetal clear. Centrifugal is defined as the apparent force. Centripetal is the exact force and centrifugal is the apparent force that is felt by an object moving in curved path that acts outwardly away from the center of rotation. Outwardly away from the center of rotation. This is centrifugal and this is centripetal. Clear? Now, acceleration due to gravity. The acceleration of a body due to the attraction of Earth towards the center is called acceleration due to gravity. It is represented by small g. The acceleration of a body due to the attraction of Earth towards the center is called acceleration due to gravity. If weight of Earth is capital M, radius is capital R. If we drop a body of mass small m from height h to the surface of the Earth, its speed will increase as it comes to near to the surface of the Earth. The acceleration of body is g. The force of the body F equal to mg. M is the mass, g is the gravitational acceleration. Mass into acceleration. This is also Newton's second law of motion. But this force on the body is due to the gravitational pull of Earth. Newton's laws of gravitation, F equal to g mm by r square. So this is equation 2 and this is equation 1. So these two forces are equal. So you can say F equation 1 equal to equation 2. So put the value equation 1 mg and put the value equation 2 g mm by r square. So just cross m and m. So g is equal to small g equal to g capital M by r square. So g is the gravitational constant, 6.67 into 10 to the power minus 11 Newton meter square per gram square. R is the radius of the Earth, capital M is the mass of the earth. So after putting the value g equal to 9.8 meter per second square, should remember all of your life, g equal to 9.8 meter per second square. Now, very important thing, what is mass? It is the quantity of a matter that contained in a body. Mass is a quantity of a matter contained in a body. And weight of a body is the force with which the earth is attracting the body. In our day-to-day life, we don't differentiate what is mass and what is weight. But mass is only m, but weight is m into g. So obviously mass and weight is different because g is multiplied, right? Now there are two differentiation. One is small g and capital G, and next slide we will discuss mass and weight. First thing first. So gravitational constant is capital G and gravitational acceleration is small g. The value of gravitational constant, oh my god, this one, 6.67 into 10 to the power minus 11 Newton meter square per kg square. And gravitational acceleration small g, it is very easy, 9.8 meter per second square. Gravitational constant is scalar quantity, it is not depend on the direction. But gravitational acceleration small g is a vector quantity, it is depend on direction. If it is towards the earth, it is minus g, and upwards the earth, it is plus g. I will explain. Next, its value remains constant always and everywhere. Its value varies at various places. Just like I am explaining previously, that it doesn't depend on capital G, does not depend on medium. Maybe air, maybe water, maybe any liquid. Capital G always same. But small g is vary according to medium. The unit is Newton meter square per kg square for capital G, and for small g is meter per second square. One tricky question: why is the weight of an object on the moon 1/6 its weight on the earth? You all know, if you have 60 kg in earth, you will feel 10 kg in moon. Never me or my student not go to moon, but it is a thing, it is a real scientific thing. The moon mass is 1/100 times and 1/4 times the earth's radius. As a result, when compared to earth, the gravitational attraction on the moon is about 1/6. Thus an object weight on moon is 1/6 its earth weight. So weight is less compared to earth and the radius is less compared to earth. Weight is 1/100 times less and radius 1/4 times less. So weight, that means g, 1/6 times less. What is free fall? When an object falls from any height under the influence of gravitational force only, under the influence of gravitational force, there will be no friction, nothing, no other force. It is known as free fall. Next, what is the difference between mass and weight? Mass is the quantity of matter contained in the body. Weight is the force of gravity acting on the body. Force of gravity acting on the body. Mass, it is the measure of inertia of the body. Weight, it is the measure of gravity. Mass, it only has magnitude. Weight, it has magnitude as well as direction. So mass is a scalar quantity and weight is a vector quantity. Mass is a constant quantity. Weight is not a constant quantity. It is different at different places. The SI unit is kg. The SI unit of mass is kg and SI unit of weight is Newton. Next, motion of object under the influence of gravitational force of the earth. Previously I told that there are Newton's laws of motion. There are three formula V is equal to U plus 2AT. V square is equal to U square plus 2AS, and S is equal to UT plus half AT square. Now these three formula will be modified according to G. Let an object is falling towards Earth with initial velocity u. Let its velocity under the effect of gravitational acceleration g change to v. Initial velocity u, and under the effect of gravitational acceleration g, its final velocity is v. After covering the height h in time t, then three equations of motion can be represented as velocity v after t second. V is equal to final velocity v is equal to u plus ght. G is the acceleration, gravitational acceleration. H is the height, T is the time. Height covered in t second. H is equal to ut plus half gt square. Relation between v and u. V square is equal to u square plus 2 gh. The value of g is taken as positive in case of the object is moving towards earth positive, and taken as negative in case of the object is thrown opposite direction of earth. So if the object is falling to the ground, g is positive. If his object is throwing to the sky, then g will be negative. Problem number 1. A stone is released from the top of a tower of height h 19.6 meter. Calculate its final velocity just before touching the ground. Initial velocity, at initial it is rest, u equal to 0. Tower height equal to total distance equal to 19.6. G, acceleration is 9.8 meter per second square. Consider the third equation of motion, that means this one. Clear? V square is equal to u square plus 2gh. V square is equal to u is 0, 2g 9.8 into h 19.6. There's a mistake, here will be h, right? 2gh this thing. V is equal to 19.6. Clear? Very easy. Next, problem number 2. A stone is thrown vertically upward. Upward means g will be negative with an initial velocity u is 40 meter per second. Taking g, problem is given that g equal to 10, not 9.8. Remember this thing. 10 meter per second square. Find the maximum height reached by the stone. What is the net displacement and the total distance covered by the stone? Distance and displacement. This is a very tricky question. Distance is a scalar quantity. It has only magnitude. But displacement is a vector quantity. It is magnitude as well as direction. So initial velocity u equal to 40, g equal to 10. Maximum height at final velocity it is 0. V square is equal to u square minus 2gs. G negative as the object goes up. So you will put the value s equal to maximum height 80. So after reaching the maximum height it will goes downwards. So 80 plus 80, 80 upwards and 80 downwards. So total distance 80 plus 80, 160. Total displacement equal to 0, because the initial displacement is the distance between initial and final. Initial and final is same position, because if you throw one stone upward, it will goes downward of the same direction and same place, right? So displacement 0 but distance is 160. Thank you for watching this video. Please like, subscribe and comment. Thank you for watching. Thank you, student.